So you're right, this is our oil-free centrifugal compressor. Unlike other oil-free centrifugal on the market, this one does not have a magnetic bearing. We use our own patented aero lift bearing technology. And the way that works, if you would like me to explain.
Yeah, for sure.
It's all mechanical process. So rather than, the controls and everything with the magnets holding it in place, levitating that rotor, we have just a layer of refrigerant vapor that as the rotor starts spinning up, getting up to speed, just lifts off that bearing and levitates with that frictionless barrier around it. So
from the refrigerant itself?
Correct.
So the refrigerant itself, and what is the refrigerant?
Just the refrigerant in the system.
Do you know what refrigerant it is?
So we are qualified with 513A, 515B, 1234ZE.
Okay.
For low GWP options.
So someone would buy this, put it in their centrifugal compressor, put some shells on it and things like that?
Yeah, so this would be going into like air-cooled chillers for data centers or comfort cooling applications. We were targeting that high lift application and obviously are then qualified for the low lift, like water to water cooling as well. So
gotcha. So this is a very weird looking arrangement. And when I first saw the video, in the cutaway, it's a little easier to understand, but could you explain how the refrigerant's flowing through this thing?
Sure. So you've got your suction on one end, down on this side, and then it's got two impeller stages. And so
one impeller here, one impeller here.
Correct.
Okay.
So comes in the stage one side, goes through the impeller, which then, adds a lot of kinetic energy, speeds up the refrigerant, and then it goes through a volute where it actually slows down, and that converts the energy from kinetic to potential in the form of pressure. And so it gets all gathered up in the volute and then out the stage one side, through our discharge, or through our interstage tube.
Interstage tube, that makes sense.
And then to stage two, where the same process happens again, you get another step of compression before it goes out the discharge here on the side.
I see. Okay, so two stages. That makes sense. You get in higher lift applications like air-cooled, right?
Correct.
So was this designed specifically to address the need for cooling in data centers, or was it just designed for a general use, or?
So it can fit in a lot of applications, but we are optimized for data center use.
Because the data centers are exploding. It's insane. Right?
Exactly.
And you either do water cooled, which uses a lot of water from the evaporation of the towers, or you do air cooled. Two primary options. So
exactly. So we're targeting that air cooled because of the water scarcity issue, like you said, and also with data center, we think the aero lift bearing is an important piece of the puzzle because it really increases the reliability. Because it's all just a mechanical process. It's very robust design. The same thing happens every time you start up and shut down. When it shuts down, the rotor just slows the rotation until it